Welcome friends. Now in this section we will study the manual of trip circuit supervision relay Schneider. So you will have a good understanding. Again, I will explain in detail. So let's open the manual for the Schneider relay. This is the manual for the Schneider relay trip circuit supervision relay. So you can see the type of the relay for the Schneider is RL 91330 and 91320. So there are two different type of relays. So we are going through the content. It has ranges, reception and storage, functional diagrams, supervision with CB closed, supervision during trip, supervision with CB open and protection trip contact, supervision with CB open, supervision summary report, external connection diagram, single pole or three pole supervision relays, dimension and type of sockets. These are important related to installation. So here you can see supervision functions, the trip circuit wiring, CB trip coil, the CB52A and 52B auxiliary contacts. So we will see the relay indication, an illuminated green light, correct operation of relay is shown, two potential free changeover contacts. Both contacts and LEDs are in series, therefore synchronized. So in this case, in MVAX, if the system is healthy, it's showing flag. But here, if the system is healthy, if the trip circuit is healthy, the green light will be on. If it's not healthy, the green light will be off. So these are the two relays. This relay has only two coils, and it is a simple relay that we have discussed, which is monitoring the breaker in open and closed conditions, and also some kind of time delay is also given here, which can be selected. And this relay has more functions. We can see in detail. This is a function diagram. Okay, so here you can see this relay has a fuse. This is, for example, the tripping coil and the tripping circuit that need to monitor it and need to supervise. So you can see this is the trip circuit supervision relay. It is installed here, and this one here you can see is the protection trip contact. This is coming from the relay. When the relay will give tripping command, this contact will close. Solid positive will travel through this contact because the breaker is closed through 52A, which is normally open contact, which is follow the CB status. It will trip the breaker. This trip coil will be energized, then it will trip the breaker. So now we will see it has two coils. The coil K is basically monitoring. You can see easily by this technique, because if the breaker is closed, this contact will be closed, and the coil 2 K2 will be short circuited or bypassed. So it means that by just knowing this theory or concept, you can see easily when this contact is closed, only this coil is supervising. So you can see easily that supervision of the coil is done through K1. So here you can see that this coil is supervised by K1, and if the breaker is in open position, then you can see CB is going through 52B. Return negative is coming up to 8 to this coil, and then positive to this coil is coming from 4, and it's going to 52A other side of the contact from here through K1. So positive is coming through K1 to this point, from here to here, and then at terminal number 4 to this contact. This contact is picked up if the breaker is open. So if you are finding difficult here to understand, you can always open the diagram that we have studied and it will be clear to you. Here you can see this is the same way from tripping coil, it is coming, return negative is coming to the coil B. So we can see this is the tripping coil from 52B, it is coming to coil B K2. It is the same drawing, just you have to understand well. And from here through resistor it is going to coil A, and positive is coming from resistor to trip coil and to coil B. So in fact this is the same diagram, and here you can see it is more electronic base. Instead of resistors, they are using here the diodes to stop the flow of current in reverse direction. So another thing that you can monitor here, this is the alarm relay, and this is basically the LED, and we have studied that LED and alarm contact both are synchronized. It means both are operated through the same contact. And here you can see, instead of giving the time constant, instead of connecting RC circuit, what they have done, they have just initiate a time delay relay at the output contact. So they have connected a time delay relay. So during transient, if the pulse is continuous more than 150 to 400 millisecond, that is adjustable, or you can order as per the ordering code. If the pulse is less than this, the alarm will not generate it on transients or on the jerks in the system or dips in the DC system. So instead of putting RC circuit, which is a rather an old technology, they have used the time delay relay here, and instead of using resistor, they are using here diodes, and they have additional module of pickup voltage control module and drop off voltage control module. So these are basically the supervision relay from the Scheneider. So here you can see they have explained the operation of supervision relay with CB closed. The LED is on and both contacts are in closed position, terminal 5, 9, 6, 10 whenever. So here you can see if the circuit breaker is in closed position, that we have learned already, and they have explained in very nice way again in this Scheneider relay. So different manuals, when you read, you will have a good understanding of drawing. So you can see through the fuse, positive is coming here, it is called solid positive, which is available on the bus, and through this and it is giving solid positive to the K1 relay, which is monitoring the breaker in the closed position, and then it's further going to through this contact the trip coil. So negative is coming to the coil 1, solid positive is coming to trip coil 52 through 52A, it's coming here, and it's giving solid return negative is coming through the tripping coil to K1 negative terminal, and the positive you can say is coming here. The coil is picked up and it's basically healthy. So it is showing that system is healthy, and green light will be on. So this timer is if it is on, then light will be on, and alarm, there will be no alarm in that case. So here you can see they have the module here. So they have pickup voltage control module installed in the relay, and for example we can select at how much voltage the relay should show that system is healthy, and drop off the hardware voltage the system should show that it is dropped off, it is the voltage are less than this, the DC trip circuit is unhealthy. So it's also monitoring the voltage level here. Here you can see they have installed, I was talking about the RC, so they have installed RC on together with K6 relay. So if there is any dip, so this again this is to cover the dips. So this timer in fact is all the time on, and this dip of 150 or 400 milliseconds they have achieved through this again RC circuit, which is installed in parallel with K6. So if there is a dip, the temporary supply to the relay will be to the K6 relay will provided by through this capacitor will discharge through this resistor, and it will keep the K6 energized for additional 150 or 400 milliseconds. This is just to cover the dips. So this, and I think in the open position, okay, now they are explaining here the different situation that can occur if the trip supply falls below the assigned drop off voltage. The drop off voltage control module will detect it, and therefore K5 will drop off and will lead to de-energize K6 and K3 after 150 milliseconds. This will result in trip circuit supervision alarm. So this is one condition. In this relay is more precise, so you can the drop off voltage. So here, for example, the wire is broken here. So if a protection relay will operate, breaker will not trip. So this is not the condition that we want. If the wire is break here, you can see if the wire is broken here, this relay will be drop off, K1 will be off. Okay, and in case broken wire connection supervision, K1 will drop off, and this will lead to de-energize K6 and K3 after 150 milliseconds. So when K1 is de-energized, in this case this contact will be open, K1-1, and K6 will be de-energized after when this capacitor is discharged, that is 150 milliseconds, and when this is de-energized, K6 is de-energized, then you can see the K3 again will be off and it will generate the alarm. So this is how this relay is working. Supervision during trip. So what he is saying, in this situation, the trip contact of protection relay and circuit breakers are closed. You can see this is the protection trip contact of the relay. When this contact is closed, you can see this relay is bypassed during this time. So bypass means the relay K1 is short circuited and it is bypassed when the trip command is being issued. So if there is not some kind of time delay here, then the K1 relay will be de-energized and it will initiate the alarm during the trip. So we will see how the relay will operate in this case. So here you can say K1 and K2 both are de-energized when breaker is closed and trip command is being issued. So you can see the operation time of CV must be less than 150 milliseconds in order to avoid the drop off of the relay. K6 is kept energized with the internal capacitor, and therefore also LED remains energized. It provides the unwanted alarm during operation. So you can see the tripping time, operation time, everything, issuance of the command and opening of the breaker, it should be less than 150 milliseconds. Normally this time is 30 to 40 milliseconds. So during this time, this K1 and K2 both are de-energized off, and the K6 will be de-energized, but the K6, the power will supplied by this again resistor and capacitor during this time when the tripping command is being issued. Both coils are basically de-energized, and in order to prevent the maloperation of the circuit supervision relay during tripping, this capacitor will provide the power and this will keep the circuit live. So supervision with circuit breaker open and protection trip contact closed. So supervision with CB open and protection trip contact close. That you can see this is another the another way. In this case, we are seeing that circuit breaker is open, but relay is giving the trip command. So what will happen in this case? That the relay K1 is bypassed, but the relay K2 is not bypassed. So the contact is still closed. In this situation, although CB has already opened, the supervision circuit is indicated via K252B and CB coil. K1 is not energized. In this situation, the trip contact can remain closed. For example, if the protection relay trip contact belongs to lockout relay. In this case, the trip contact remained closed until the trip was recognized and lockout relay would be reset. So this is another condition. For example, if the tripping is not done from the relay, because the relay contact is after when the fault is clear, the relay contact is reset. But if the tripping is done through a lockout relay 86, the tripping is continuous. So what will happen in this case, that we have seen during tripping, the delay and the supervision will be done by K6 and it will wait for 150 milliseconds, and during this time the breaker will open. When the breaker will open, so you can see that fuse through the DC will travel from the tripping coil to 52, because now the breaker is closed. So 52, this is the normally closed contact of the circuit breaker, so it will be closed, and K2 will be energized through this contact. So it means when even this relay, Scheneider relay, will work perfectly with the lockout relay, and this condition is also satisfied. For example, now we have seen trip command is before breaker was closed and trip command was issued. In this case, K1 and K2 both were bypassed or short circuited, and the time of issuing the trip command and opening of the breaker is always less than 150 milliseconds. And if somehow it is more than 150 milliseconds, which is not possible, all the breakers are 30 to 40 and maximum 50 milliseconds, it takes time, so then relay will give maloperation. So now it is giving tripping and breaker is being open. Now breaker is open, so in this case you can see the negative is coming, breaker is open, 52B is basically normally close contact. So if breaker is open, it is close, it is opposite to the breaker status. So here you can see K2 indicator negative is coming up to K2 and positive is coming through, you can see the protection relay, which could be 86 lockout relay. So when someone come and reset the lockout relay, then you can see the path will be positive to K2 will be provided. Now this is open, for example, through K1 again. So this relay is giving protection also. When CB is open, protection relay is still giving the continuous trip command, which is case of 86. So now we can see this is a little bit complicated. This we have already studied, so this diagram I find it very helpful, so you can go through this manual. So when CB is open, you can see solid positive is coming through this coil, and from here it is coming up to the K2, and negative because breaker is closed, so it's passing through the trip coil. So in this way, when CB is open, the coil K2 will pick up and it will give the indication that trip circuit is healthy. So the following table resumes the four situations explained before. The situation K1 and K2 would be in the trip circuit normal working condition. So supervision with CB closed, trip contact open, CB status closed, K1 energized, K2 de-energized. So I have already explained this table, and you can, when you review it, you can counter check this table with the situation, so it will be really helpful for you to understand. Now they are explaining that at what voltage levels what are the standards and consumption, which is basically the power consumption, how much milliamp this relay will draw. And this is the external connection diagram. They have shown how you have to connect the relay, and this will really make the life of commissioning engineer very simple. And again, external diagram, how they are connecting the relay, this relay has single pole mechanism, and how you will connect the relay with 3-pole mechanism. So each relay has separate trip coil, so you will have to buy another relay, and you will connect the wiring as per this diagram. And these are the dimension. This has only 2 coils, so this relay can be installed to the breaker which has only one mechanism. So this relay will be used at up to 132 kV normally. At 500 and 220 we may find single pole mechanism. This is basically the base of the relay. This relay, as you can see here, 2 plus 2 plus 2, 6 coils. So each pair is for one pole of the circuit breaker. So this is all about the Scheneider relay manual. So they have explained the operation of the relay and the diagram in very excellent way. So this will be really helpful for you to understand the supervision concept. I will be making this manual available for you to download and you can study. Hopefully it will make your concepts very clear. Thank you.